Hello students, today we will discuss the process of determination of molecular weight of unknown protein by STS page. By the method of STS page, how we can determine the molecular weight of an unknown protein. This is achieved by comparing the distance traveled by protein of known molecular weight to that of protein of unknown molecular weight in the same gel. That means by comparing the distance traveled by the protein of known molecular weight to that of unknown molecular weight run in the same gel. This can be explained by this graph. Suppose this is the gel, polyacrylamide gel, then these are the two wells. In the well 1, proteins of known molecular weights, a mixture of protein of known molecular weight is loaded. These protein of known molecular weight are known as marker protein or marker. And in the second well, protein of unknown molecular weight is loaded. Electrophoresis is started, and at the end of electrophoresis, the gel is stained using Kumasi brilliant blue CBB, and we visualize the bands. So suppose at the end of the electrophoresis of STS page, we get these bands of protein of known molecular weight, which get separated according to their molecular weight and travel different distance corresponding to their molecular weight. That means that protein having maximum molecular weight will travel least distance, and the protein having least molecular weight will travel maximum distance. Similarly, the protein of unknown molecular weight will travel certain distance and will form a band in the same gel alongside the band of marker protein. In his next step, what is done, that is, the RF value of individual marker protein is determined. What is RF value? RF value is the relative migration distance. This is the relative migration distance, means the distance traveled by the distance moved by the protein, that marker protein, divided by the distance moved by the dye. Suppose this is the suppose here it is the distance moved by the dye. So by dividing this value by this value, we get the RF value for, suppose we have to determine the RF value of this protein band. So by dividing this distance by this distance, we get the RF value for this protein. In similar way, we get the RF value for all the protein molecule, and with the help of this, that means by determining the RF value of individual protein, now we know the RF value as well as the molecular weight of each protein molecule, each marker protein. By determination of the RF value of each marker protein, we plot a graph putting RF value on this x-axis, and the log of molecular weight of each protein on y-axis. By this method, we get a straight line. This is the straight line of the marker protein This straight line gives the idea about the distance travel or RF value against the molecular weight, log of molecular weight. So this we will get the a graph, as a line or graph of known protein of known molecular weight. In the next step, in the similar way, we determine the RF value of this protein. Now we put the RF value on this graph. Here we get a point here, and by this point we get the log of molecular weight of this unknown protein as well. By this method we can determine the molecular weight of unknown protein using STS page, and by comparing the RF value of the marker proteins. So these are the molecular weight of some of the proteins, like these are the myosin 200 kilodalton, beta galactoside 116.25 kilodalton, glycogen phosphorylase 97.4 kilodalton, bovine serum albumin 66.2, carbonic anhydrase 31 kilodalton, soybean trypsin inhibitor 21.5 kilodalton, lysozyme 14.4 kilodalton. So students, hope you must have understood the process of determination of molecular weight of unknown protein by STS page. Thank you.